All right, welcome everybody. It is Wednesday, March 30th, and it is approaching fast. April, tax day is coming up, apparently. There's one of the certain things in life, including the pandemic and many others that we have found out over the years. And we're excited about today's program, a great day for you all. I happen to be today in glorious Brownsville, Texas, a few miles from SpaceX and South Padre Island. And before we get rolling, Dr. John Sibley Butler, will you get us some music?
Well, it ain't no use sit and wonder why, babe. It don't matter anyhow. And it ain't no use to sit and wonder why, babe. How you doing?
Excellent. John, how are you today?
Fine. I've been sitting and wondering why on a lot of things in the world. The whyness relates to what is absolutely going on in the world today from an international point of view. The whyness relates to why is the market seeming, the market that can see it all certainly cannot see it all, but it seems to be doing fairly well. The whyness is why do we have so many immigrants because of war going around the globe. And one big whyness is what's the relationship between what's going on in the world today, our Western civilization, and the future of prosperity in the world. I think these are big questions that we must all ask. And so I've been sitting and wondering why.
Absolutely, absolutely. Well, you know, we're going to get into that in a moment. Llewelyn King, how are you, sir?
I'm very well, thank you, Andres. I'm glad that Johnny is asking these questions, and I'm sure that by the time I finish speaking, he'll be prepared to answer them.
Well, you know, I'm glad we're in for it.
Welcome to the madhouse, Dan, where we try to put technology into its perspective as being totally dumbfounding and beyond us.
There you go. There you go. Well, Dan Diehl, how are you, sir?
I'm doing well today. Thanks for having me.
Absolutely. Well, you know, we are delighted that you're here with us. You're going to take us into one of these other areas that we love very much, smart buildings, and what does that mean, and so on. But before we get there, I wanted to, for those that are listening and don't know much about you, to introduce you and make sure that they get a bit of on your background. So Dan Diehl is the CEO and president of Aircuity, and he'll tell us more about the company. He spent a significant amount of time prior to his current executive leader role as VP of Global Sales and Marketing. And then before that, he worked at some other companies, including Lutron Electronics and Synergy and Johnson Controls, where he worked a long time. He has a BS in mechanical engineering from the University of Maryland and an MBA from Villanova University, which unfortunately for him will lose in the Final Four to Kansas. Me being a
welcome. Welcome. That's what we welcome. You know, I mean, he's worse than me and Llewelyn.
No, but we're delighted to have you, Dan. And so Dan, you know, you are a great entrepreneur driving this transformation from the building, from smart building point of view on where the future is going to look like. And usually when we start with an executive like you, we ask very quickly, sort of any lessons learned, any unique transformation or acceleration that you have seen due to the pandemic and COVID to the business itself. And then the second part of the question is, what does 2022 look like for your business?
Yeah, well, I guess they're very related. It was interesting, I think, when the pandemic started, a lot of people thought that Aircuity as a company measuring indoor air quality was going to go through the roof, and air quality obviously became front and center, especially in the built environment, and ventilation management, ventilation optimization kind of really became a big thing. But it's actually been an interesting ride through the last 2 years. What we saw through that pandemic was a lot of the what I would say kind of the commercial real estate market, especially with multi-tenants, were actually a little bit more on the sidelines than initially reacting, not knowing when people were going to come back, and when they did come back, how buildings were going to need to operate. And so it was a little bit of more of a waiting and a holding period. We're fortunate as a company that we do a lot of different work. So we're not just involved in commercial real estate. We do a lot of research spaces, a lot of higher education, K through 12, life sciences, government. So what I think happened at the tail end of the pandemic, which is actually pretty interesting, and kind of which answers the second part of your question, is what's 22 look like is, and I'll tell you a very quick story too in a second, but is that what really started driving business was really the convergence of two mega trends, which are really decarbonization of the built environment and the desire to have indoor air quality, have smart buildings that were going to be more adaptive to this new variable occupancy type of approach with this, what's happening in buildings today. And so we started to see business really pick up as customers started to, I guess, from ESG pressures and just other kind of awakenings that's happened during the pandemic about the basically the global agreement to get to 1.5 degrees by 2050 and to get to net zero. We just started to see a lot more people adopt and understand that ventilation optimization and an efficiency first mindset was the first step in a path to net zero. And so 2022 looks pretty incredible for us. We had a record year last year, and we see that continuing to increase and even grow faster for the reasons I just stated. So,
Dan, let me ask you this question. This semester, I'm a professor here at the University of Texas at Austin.
Yeah.
And for the first time, we were asked, would you like us to measure the quality of the air in your classroom?
Mm-hmm.
We were asked to measure the quality of the air in the office. And you talked about new business models, and you talked about the mega trend. My question is, given these two mega trends, how does it all fit together? So I understand that I need to know the quality of the air in my office for certain kind of purposes.
Mm-hmm.
And what kind of business model would that lead to? Would that mean they're going to change out the filtration system? They're going to put certain kind of coal in the filtration system? So what's the business model of understanding the air quality? It's kind of like, okay, be aware of falling rocks, right? So my question is, what's the business model? I understand it, but what's the new business models that comes out, the relationship between knowing the quality of the air, other than destroying certain industries, and creating new business models?
Yeah. Well, that's a great question. And I think largely, well, I guess because I'm in it and I live it every day, probably easier for me to answer than others. We still are relatively a small company that operates, with in these, kind of oligopolies like my previous company, Johnson Controls, Siemens, and Honeywell, these big global, building automation, type of companies. We Aircuity are relatively still smart. We're agnostic and we work with all of them. And I think the business model question is it's really just one of adopting proven technologies. We measure indoor air quality different than the built environment has done it for a long time. And it's not just Aircuity. Let's say, like, if you look at what's happening with the International Well Building Institute and other organizations that are promoting health and wellness in buildings, the business model is probably as simple as you can't control and manage what you don't accurately measure. It's just a simple kind of fact in life. It's, maybe a little bit more tuned as an engineer to think that way, but you first got to get an accurate measurement. You got to have it as an input. You have to then, analyze and understand that data and what it's telling you. And hopefully, what we do is we integrate that directly into the building control systems so that it automatically, smart buildings, right? They manage the kind of like your thermostat does, right? It manages the temperature without you having to think about it or adjust it. So what we do at Aircuity is we're monitoring that air quality on a space-by-space level, and we're controlling the ventilation accordingly. So the example is, you know, if a space is unoccupied and there's not a lot of people in there, there's not high particle levels, there's not a lot of CO2, we take the ventilation down. And so you can save tremendous amounts of energy for that. When their situation is that there's poor air quality in that room, you want to bring the amount of ventilation way up. Well, then conversely, you may say, wow, what if, like, look at what's happened in the last several years. You know, we've got projects in California, Seattle, Australia. What happens when there's an outside, you know, fires outside? And now all of a sudden, you're not gonna improve your situation of your building by bringing a whole bunch more outside air, what's called fresh air, if the air outside is dirty, right? So you need to understand that and say, oh, the outside air is bad. Hopefully my filtration system is working. I want to understand how my air handling unit is taking care of that air as it moves through that air handling unit and what's it supplying to my space. So what ends up happening is, I would call it just, it's about, first of all, accurately measuring it, tying it into the system so it becomes smart buildings, getting the benefit of both energy efficiency and improved environments. You don't have one or the other. In the 70s, we tried to solve for energy, and they put outside, they boarded up outside air dampers. It saved a ton of energy, but it caused a lot of people to get sick in the buildings, right? So we know what that looks like, right? So you need to optimize and solve for both. And it can be done, it is done in today's buildings, and it can be done to give you the best of both worlds, you know, optimum energy efficiency, maximum health, wellness, safety, and productivity. And then you can now also lastly understand, okay, what is happening in my building? Once I see that data, I can now alarm on spikes or events that are happening, systems that don't seem to be working properly, et cetera. And so that is the business model of the future. It's intelligent, accurate measurement, integrated to automate these buildings. It's not, you know, it's proven. This isn't like, you know, early phase, let's see if this works kind of thing. I mean, you know, we're in Apple's headquarters, we're in University of Texas, we're in 250 universities actually around the country and around the globe. And so this works. It's so a proven concept.
Quick follow up on that, Dan. So there is this something called, for our audience, if you can explain it, the safety rating, safety rating, and they claim that, you know, it's up and coming. It's been around for a few years, not many. I think J-Lo is one of the spokespeople, and they
You're right.
They claim 33,000 projects, $3.5 billion, a billion square feet under this kind of. So is this rating helping your business or not, or what can you share about that?
Yeah. We're very supportive of just because it supports everything I just said, which is it supports accurate indoor air quality measurement. It supports a continued monitoring of those spaces over time. So you can't just, it's kind of a joke in the industry, but it's like, you know, if you get like a LEED certification on a building, you get a point for putting a bike rack outside or something, you know, where you kind of get the point, you check the box and you move on. Really promotes the concept of continuous monitoring of smart, healthy buildings. So you can't just do something, check a box, put a stamp on your window and say, wow, I have this great building. And it's only, you know, buildings are really dynamic and they change all the time, every day. Just I gave you the example, like what if an event's happening outside? So really supports kind of everything I just spoke about. I don't need to repeat it. And so I'm a big believer of that. And we do a lot of net zero projects. We do a lot of well projects. You know, kind of just healthy building projects in general, where people may not go for well certification for one reason or another, but they still want all the benefits of well. So we're involved in many of those projects around the globe.
Well, one other follow-up. So, you know, I'm running from a building at the University of Texas, for example, or in a building, and I see a friend running back to the building. I said, where are you going? The air is bad in there. And he said, well, I'm going to get a whiff of that because there's a big lawsuit and I need to have some in my system when they get sued, because when we start suing and having class action lawsuits, I want a whiff of that in my body so I can sue them also. Hello. One of the great things about technology are the unintended consequences. And what I see is that it's like, I'm a Vietnam veteran, and the guy says to me, oh, I should have got a whiff of that Agent Orange. People are making all kind of money on the Agent Orange. So one of the unintended consequences that I see, well, it's a great model, but the legal folks would say, your building has caused the injury, it has caused the health problems. You're right now in the same situation where tobacco was 60 years ago. So then I love the business model, but I think there might be, I'm not sure, some unintended consequences around legal.
Well, the unintended consequences on the flip side of that coin, right, are if other buildings are now doing this and they're providing these systems and they're providing better indoor environments and they can measure and quantify that, and you don't do that, you are liable on the other side of that coin as well. Right. So the idea of burying your head in the sand and saying, to me anyway, right, I'm not going to go from a legal perspective and people trying to game the system, but it's but when you talk about that, there's always two sides of that coin, in my opinion, and I think that there's enough, more than enough cases where people are providing a known better quality, healthier, safer, more productive environment by managing the amount of carbon dioxide in the air, by monitoring particulate levels, by monitoring, trying to control good relative humidity, et cetera, and by providing better filtration, et cetera. And if you're doing everything you can to provide the best system, it's not impossible. There's no safety, it's always a relative argument, right? And to me, there's both sides of that coin. That's just the way I look at it. There's both sides of that coin. Somebody right. trying to say, well, I'm going to bury my head in the sand, I'm not going to do anything. They could just be just as liable for the people that are trying to do everything they can and provide the best environment they can. So
I think so. I just think it's, I think it's there.
Yeah.
Llewelyn?
Yes, please. Dan, I found what you had to say very interesting on a number of points. One, I like the basic idea you have that to look at what you have and make more of it. Particularly, I would have been very wrong at the beginning of the pandemic. I thought that indoor air quality would become a huge seller, that you would see restaurants with signs which said our air is scrubbed or filtered or something to induce more people to come in. It didn't happen. The other thing is people who use buildings, in my experience, or up to this point in time, have been uninterested in the quality of the air. The two questions, and I used to rent office space in Washington over many years in several different buildings, had a little company and we moved around a bit. The only question you ever got from the staff was, it's too hot or it's too cold, do something. But no question about the quality of the air. When first we moved into buildings where you couldn't open the windows, that bothered people. Psychologically, it bothered people. And then they got over it and nobody looks to windows to open anymore. It's amazing how we've adjusted to that. But personal habits have improved the quality of air, particularly smoking. In newspapers, which is my business, smoking was endemic. I mean, it was very heavy. In the Washington Post, you'd see, ashtrays overflowing everywhere, the air full of smoke, as it was also true in restaurants and pubs, etc. So that habit change has cleaned the air in that way. But the unseen quality of the air seems not, on the whole, to bother people so much. It is either temperature or something like smoke that they can see that bothers them. Is this a big sales problem, that people are not terribly aware of the quality of the air? In this apartment, I'm in a converted mill, beautiful apartment, but we get a lot of dust. We don't know why we get a lot of dust. We've asked the HVAC people and everybody. They don't know. There's no road, there's a river outside and there's a lot of dust. But nobody does anything about it, and we complain in a desultory sort of way because we've got tired of complaining, and nothing is done about it. So this is really virgin territory to really get people excited and interested, and particularly landlords committed or feeling responsible. Do you find that?
Yeah, that's overall. I think the question is again, it's a hard thing to understand if you can't, especially it's really hard if you look at like small particles. So what COVID has taught us all improved is that aerosol is like 0.3 micron particulate levels that basically COVID travels in the air, stays in the air for a long time, and gets transmitted. So now that we understand that, it's one really good benefit of COVID in terms of awareness of indoor air quality, right? But I still can't see that. I can't walk into a space and understand that they have poor ventilation, right? I can't understand if I'm going to be really high risk or really low risk. Not a lot of COVID got spread outdoors, right? People got way more sick way faster in poorly ventilated spaces indoors. But to your point, the question is, well, how do I see that, right? How do I know that? And I just go back to the point of it's not a secret, right? So, I don't think this is going to be a secret. It's like we do much better as a company with owner-occupied commercial real estate, with higher education, and with life sciences. These are the customers that have their workforce, their people going into those buildings every day. They want to provide a better, healthier, safer, more productive environment, and they care about their workforce. And they want to attract and retain the best talent, right? So there unfortunately is going to be a dichotomy in the built environment of the people that are going to want to know and manage that and communicate that best in class environment, which is what Well's trying to promote. And they are extending that to K through 12 and into restaurants, into malls, and whatever else. Basically trying to say to people, hey, if you have a WELL certification on your building, you can trust that this building has been looked at by professionals and is doing everything that they possibly can to provide the best in-class environment. And so it is trying to bring that unseen or unknown to the forefront to show you that there are institutions and organizations that are making this step forward to provide better indoor environments.
Thank you, Dan. As a follow-up, what about heating? One of the things I hear a lot about is that buildings discharge heat, often with deleterious impact on cities, especially like New York, where you've got so many high buildings discharging heat into an already hot city. Is that improving? And as an additional question, I hear a lot about rewiring buildings for direct current. Do you get involved with direct current in buildings at all?
Well, buildings are going through a massive change, and they're going to continue to do that for 10 to 15 to 20 years, maybe longer. But everybody's talking about the buildings are going to be decarbonized, right? So you're going to get rid of gas reheat and natural gas systems that heat buildings. This isn't going to be an easy thing to do because of the energy effectiveness of gas and the current systems are set up that way, right? So as people look at switching over and decarbonizing buildings, they're looking at new heating sources. Much or some of that's going to be electric. Electric doesn't work everywhere. It's going to work okay in Texas. It's going to be a lot harder to do that in Boston or Toronto or New York City. And as well as the electric load to those buildings, to your point, is going to have to be dealt with, and the grid's going to have to be dealt with. So one of the first things I started out saying to you guys was that, like, as you see this transformation occurring in the built environment, this is just interesting, is you really do have to think about taking your efficiency base load down as much as you possibly can, because now you're solving to a much lower problem or much lower base load. And you can start to look at clean energy supply. Hydrogen will become a new fuel source eventually, et cetera. But buildings are, without a doubt, globally going to turn much more towards electrified heating sources to help in this decarbonization movement. We're seeing it with customers already. So,
and Dan, I agree. People have long complained about buildings that make them sick forever. They have complained about buildings that make them sick. So it's a great technology.
So Dan, real quick, I'm curious. So we're talking about smart buildings, but tell me real quick, what is the technology that Aircuity has? And could that technology work in airplanes and cars? I think the airplanes and cars are probably a far more dynamic market. So I'm curious, is that a target market for you all? What is exactly
Yeah. We serve the built environment. I mean, cars do have some technology that's in them already. And actually, some people don't know this. I wouldn't say most people, but a lot of people don't know this, is that, airplanes actually do already provide some of the better indoor environments that are out there in terms of the amount of air change rates they have, HEPA filtration systems they have. They're very, tend to be very high quality environments. The problem with airplanes is the proximity to the people next to you. So even with phenomenal ventilation systems, when you're that close to somebody, it's really, really hard to completely mitigate any risk associated with being next to somebody that has like COVID as an example. But so we, Aircuity, we're a centralized multiplex air quality sampling system, and that's a kind of a mouthful to say. Basically, we provide a centralized sensing suite, and we bring air samples from around the building to one location, and that allows us to provide continuous calibration of the sensors more easily. It provides us a simple integration to a building automation system, et cetera. So we're able to more accurately measure air quality over the life of the building and do it much more economically. We serve the built environment. So we are K through 12, commercial office, life sciences, higher education. It's tends to be 50,000 square feet buildings and above. We're not even residential.
So again, help me understand, as a, electrical mechanical guy, managing the grid or managing all kinds of things. So I deploy sensors. You don't make the sensors, somebody else does, and you are managing and monitoring and optimizing, that information to then help my ventilation turn on, turn off, and do things.
No, we actually make the sensors. What we're doing is really kind of deploying a higher quality, higher grade sensor, and we're also calibrating and maintaining that over the life of the building, and then we're integrating that again into the building automation or lab control system to affect ventilation. So ventilation, instead of becoming a fixed kind of amount, we provide less when you don't need it. We provide much more where and when you need it. So now you get that best of both worlds, so to speak, in terms of efficiency and health and productivity.
Yeah, and then real quick for the audience to understand, do you make the filters at all? And is there any opportunity of creating better?
Yeah, we don't make filters. We help customers understand if their filtration is working effectively, because we're measuring particulate levels coming from the outside and being supplied. So after the air goes through that filter, we take a measurement before and after, so you can actually see how effective your filtration is working. During the pandemic, many customers, I would say, probably almost all customers, the whole world, has increased their filtration basically strategies or kind of so they've gone from like what's simple. It used to be, it's called MERV 8, and it's basically how effective your filter is at removing particulates. And most have gone to MERV 12 and above. 12, 13, 14. And then as that number increases, it just basically takes more particles out of the air and cleans the air more effectively. Just that's the simple version of it. Right. So people are providing better filtration, and that's just, ideally you want to have higher ventilated buildings, and you want to have better filtration systems, and that's going to remove particulates from the air, and it's less particulates that you breathe in. These small particles, just to understand it, I mean, they go through your human defense systems. They go right deep into your lungs, which is part of you probably read and heard about this, but COVID, it's one of the things is you're breathing it in and it's going deep into your lungs. You don't even know you've breathed it in, and it sits there and it starts to, kind of advance without you even knowing it for a week or two until it really takes full hold. And that's why small particles and small particle measurements are so important. In health and wellness, and people just don't realize that smoke is a really good example of it that we were talking about earlier. That's why it's just so unhealthy for you. It just gets really deep into your lungs.
Sure. Llewelyn?
Even if you're a bystander, not your smoke.
Is reducing energy consumption part of your mission?
It is. It's core to our business. I mean, we don't talk about one or the other. We talk about we talk about, and as you've heard me talk about, we talk about the benefit of indoor air quality and efficiency, sustainability, decarbonization together always, because our first and foremost, you can't have one without the other. You have, buildings have to do both going forward in the future. So
are we seeing improvements in the basic technology of dehumidifying air, which is air conditioning largely, right? Which used to be hugely energy intensive, and most homeowners know that if they're running air conditioning, they're going to get a big bill that month. Is that improving? Do we have new technologies for getting the moisture out of air?
Yeah, it's improving dramatically, and there's millions or billions of dollars going into improving it even further. There's new technologies like VRF systems and variable refrigerant flow systems, and there's just a whole bunch of new technologies that are out there that are going to help the I think it's projected to be over 25% CAGR growth industry, HVAC in general, over the next several decades. And the reason for that is kind of like the world from the middle class is evolving. The world at places around the globe, whether it be China or Africa or Australia or those places, the world's getting hotter. More people need air conditioning. More people need efficient air conditioning. So there's massive investments going into that side. We work with all those companies. We don't do that. That's not our business. We try to optimize what they're doing, right? Because the less, think about it this way, but the less ventilation you need in a building, the less air conditioning you need, the less energy you spend. So the goal, our message would be optimize your ventilation because it's going to save you a lot of money on your equipment. It's going to help you provide a better environment, and it's going to save on your operating costs. That's our message. So,
that Harvard University has a clean air institute, and that's what they do. I've worked with them in the past, and they had everything with the COVID coming out. They had things that you could spray in the air. It would clean the air itself. So there's got to be an interaction between the business and all of the research that's coming out of the Clean Air. I think it's called the Clean Air Research Institute at Harvard University, and it's like clean water. This research has been going on, but to interact with the buildings, like you said, if you can interact with the buildings, then it's really a fabulous thing.
So Dan, real quick, also try to understand a couple more things. So when we talk about clean air, does that mean also, or how important is it for building owners, the notion of eliminating carbon monoxide or methane or any other harmful gases?
Yeah, well, you're getting pretty technical if you're okay. Yeah, so so what we actually do is we do a lot of work in critical environments, it's called, so laboratories or research spaces, and we have sensors that are measure TVOCs, so it's total volatile organic compounds, and real simply, they're harmful gases. So to use your language, you nailed it. So those harmful gases can be measured in those types of environments where they may exist, and we can control the ventilation and alarm environmental health and safety, infectious control personnel, et cetera, on if a space is having an event and there's a situation. And we do that in a couple of different technical ways. But in the end of the day, it's TVOCs and harmful gases are important to control and understand, just as CO, carbon monoxide, is, just like CO2, carbon dioxide, is, and humidity you mentioned earlier. All of those are important indoor air quality attributes that should be understood if you're going to understand what's happening in your buildings.
So Dan, let me ask you this: How is the market responding? What's if you look at X number of buildings in X number of places? I don't know how you measure it, but if that is the parameter of your market, how's the market responding to the idea?
Very well. I mean, I as I said earlier, I mean, our business is doing very well personally, and I also think if I just had to say, how do I see what's happening in the market, being involved in it over 30 years, is people are now aware of indoor air quality. I think everybody universally, which I'm very happy about, is committed to improving the planet and stopping global warming and getting to net zero. So we're seeing way more buildings designed to a net zero standard, meaning, again, that they have solar and other clean energy supply, and they're reducing their energy consumption, and they're just providing better environments. So we're involved in a lot of those. And I think there's a public awareness now that wants to, they see J-Lo, you talked about it, right? IWBI, they see them promoting, well, and so the awareness on indoor air quality, the awareness on efficiency, the two things that are big to our business, are certainly higher than they ever have been. And again, I would just repeat earlier that more and more institutions with this war on talent, this war for talent, and this war to attract and retain the best employees and to have those employees be productive and well. And I mean, truth be told, not everybody's going to go back to the office tomorrow, but a lot of employers, if you see the surveys and read them, I mean, they want people back in the office to some degree, right? They're not going to be there like they were 5 days a week, and they're not going to commute, but most places that we see and go, what I think you're going to see, actually, this is just me speaking, so this is just my opinion, right? From everything I've read and seen, is I think there's going to be less square footage of buildings because they're going to be a more highly variable occupancy in buildings, but they're also going to be a much better quality building. That's what I see happening in the world. I see it kind of happening in New York right now. Building quality is going to improve. They're going to be smarter. They're going to be really better environments. And there's, the big banks and the big tech firms are going to want to attract people into those campuses, and they're going to provide a really premier situation for them, make sure that it's safe and health and wellness. And then but there's probably going to be less, and they have to be more dynamic because they're going to be occupied at 20%, they're going to be occupied at 80%. So now you've got a building that's got to be a really dynamic building. And that's a challenge. It's not a challenge, it could be done, but it's a challenge from a design perspective, right? Of how you operate that building.
Yep.
And can I ask you, how do you get the particulate matter out of the air? Are you using old-fashioned filters, or do you have sophisticated new technologies to capture particulate matter in the air?
Yeah, there's some new technologies, and there's also just classic old school filtration, right? Which we talked about already, which is just upgrading your filtration strategies. There are some new technologies to systems that attract particles or remove them from the air if it's a return air system. So there are strategies, and then there's also just the movement, the amount of air in a space. It's called air change rates, but it's like basically if you have a box and you put air into that box, how often do you recycle every bit of air that's in that cube? And that's called like an air change rate, right? And so if you increase the amount of ventilation in that building, that also means that you're moving more air through the building, you're bringing it back through the filters more often, and you're just cleaning it more. So the two—
Is the basic shape of the building a challenge to you? Is it, for example, harder to do a 90-story building, spindle building in New York, or a 2-3 block big old-fashioned building that's only 5 stories high, say?
From our technology, it's not harder, but from an HVAC ventilation management perspective, the HVAC system that we end up controlling on top of, that's challenging. It's ventilation, what's called ventilation effectiveness, older buildings are worse than newer buildings, and airflow movement in buildings is always going to be a challenge, or should be considered when you're looking at improving or affecting indoor air quality. So, but the simple answer is yes. The buildings are all different. Unless, some places in the world now, they just put up the exact same building, square box, and they just multiply by 1 million. But we see very few of that. I mean, buildings tend to be extremely different.
I was going to add the point, John, that the market size is tremendous because, if you take the sort of the 28 million industrial commercial buildings in the US and the 145 million homes, you're talking about, almost, a billion square feet, to go after. And it's I don't know if that number rings a bell with you, Dan, but it seems like it's a huge opportunity, which means that the valuation of Aircuity when it tries to go public should be very large.
Yeah, from your list of guys.
What I was wondering is, Are the sensors standalone sensors, or do they interact with can they interact with a central station somewhere in the city, as we talk about smart cities and smart businesses and buildings? So do you see where the buildings are standalone, but I'm sure you have it such that the air quality can be measured by a central place in a city?
Yeah. I mean, we can give our information, our data to anybody via API.
No, I mean real time.
Yeah. No, we can integrate to anybody. If the building owner wants to give that data out and they say we should, that's their decision. That's not Aircuity's decision. We can aggregate data. Well, I mean, we Aircuity, when we collect all this data, like we can't give out somebody's data, right? That's their data. But what all companies can do is we can look at all the data in whole, and we can say, buildings of this ilk in this area tend to have this efficiency or this indoor air quality kind of profile without naming names. So but that's it's important to note, right? That's up to the building owner or operator. That's not like public information. We can't show people's data.
So Dan, real quick, how much of your system is a AI machine learning capability system that takes into consideration the weather outside, the heat temperature, and the patterns inside the building? How much is your system learning on its own versus different folks managing the thermostats on their own and whatever is going on?
Yeah, a neat question to kind of think about. But our system, we're collecting and monitoring data all the time, real time. And then what you start to do is, like a lot of businesses, you write algorithms to try to help your customers. So our customers just, we're giving real time signals to the HVAC to react. What the real AI aspect of our business is to try to help environmental health and safety professionals, as just one example, infectious control or animal research facilities, try to just help them get the data in meaningful, digestible, meaningful ways to them that they can do something with. So that's more than anything what we try to do, is to say, wow, how long are these events in your building lasting? What's the highest level they're reaching? Should you want to consider changes in your strategy or your program? So we just try to take that data and constantly feed it back to the customer in better and more useful ways to them. From a machine learning perspective, meaning we haven't taken that next step to say, okay, now let's start to do different strategies in different buildings and figure out which one's best and everything else. I think that's kind of the next frontier, and we do have some data analysts and stuff, and we're kind of working and thinking on some of that stuff today. But I will be honest with you, I think that's probably the next frontier, if you will, the next maybe 3 to 5 years, where we'll probably start to do a lot more of that. As what the one fundamental truth is, you actually need a really good data set. So you need a lot of installations to try to get meaningful, information from that.
Right. So real quick, Dan, when people come to you guys, what are the top 3 reasons they buy your technology? What are the drivers?
Efficiency. They want to save money, right? So you want to optimize ventilation to save money. The second one is they want to improve the indoor air quality. So they want to have demand control ventilation, the positive side of that, right? So more ventilation where and when they need it. And the third thing is they want accurate indoor air quality measurement, so that they can understand their filtration strategies, understand the air quality that they have, et cetera. So it's about savings. It's about the productive and health and safety and wellness benefits. And then it's really just about the data and the analytics that they get from the system. They're the three primary drivers.
So in terms of savings, I'm curious if you can share the data, but for every dollar that I spend on ventilation, if I buy your system, how much do I save?
Yeah, so there's three simple equations. The first is not all buildings are alike, right? So commercial buildings, non-laboratory buildings, $1 invested, right, is going to get you between 20 and maybe 35, 40 cents if you're depending upon where you're at in the country. of return. So it's going to be a 2.5 year, 3 year to 5 year simple payback on a commercial building. That's got a return air system, a commercial office building, right? If you go to a laboratory, these buildings have 100% outside air. So they're not returning air typically anymore. They're bringing in air, heating, cooling it, and then blowing it through the roof and sending it high into the sky. Those buildings are hugely energy intensive, and our projects for those are typically a 1 to no more than a 3 year simple payback. So, you know, for every dollar invested, you know, you're getting a minimum of a 35 to 40% return on that investment, sometimes much greater. And actually what you're seeing, which is interesting, I don't know if this interests you guys, but what you're seeing is, I kind of jokingly use the term of carrots and sticks, but if you go to New York City, which we were talking about earlier, you know, Boston, Seattle, the energy codes are getting significantly more strict, and they're penalizing buildings that aren't as efficient as they should be, but they're also offering really good incentives for people to get efficient. So we have projects that are $1 million projects that are paid for with incentives greater than 50% of the total project. So these projects are home runs for customers to implement and to do. And then the last equation, which is really important, is decarbonizing buildings, right? So if you take that initial project, let's say a lab project, and somebody invests $1 million, and let's say they save $500,000, so it's a 2 year simple payback. That's your operating cost. That's annual, every year saving $500,000. All right, good for you. But now when you go to decarbonize that building, you're also significantly reducing the amount of future spend you have to decarbonize that building. You know, and you're removing therms directly from it. So you're actually getting a benefit of reducing therms, and you're getting the ongoing kind of the savings from future spend that you're going to have to do. And then there's the world and is now starting to think about carbon pricing. So now if you look at the savings that you're going to get, if you look at how much carbon you were to remove, that equation, customers are showing us, it's like $1 returns 500% return on investment. I literally was blown away. We just had a customer show us that for every $1 they spend on our ventilation optimization project, their carbon equation was a 500% return. Wow. Including all those benefits, right? So ongoing operation, future spend, price of carbon, and just, you know, carbon removal. So it's and that's just, you know, it's, I don't know, it's unequaled.
Dan, let me give you another business model.
Yeah.
If underwriters will utilize it like we did smoking. In other words, if I work in a building that has been certified as clean air, then insurance companies, health companies would drop my how much I pay for my premiums on my policy. We certainly have done that with cigarette smoking, and we've done that with other things. And if you the workplace and say, I now work in a safe building, then it seems like to me that the underwriting for the insurance companies would be take that into consideration. Do you see that as a business model and a selling point? If you do, just send Andreas a check, because this is free advising.
Okay. Free advice. I'm going to take your idea and I'm going to run with it, right?
Yeah, there you go. Run with it.
We'll talk about compensation later. I love the idea. One of our customers talks about it all the time. University of California, Irvine, they implemented a smart lab program with Aircuity, and they actually have the lowest incidence of you know, health and safety incidences in the whole UC system. And it's by a long shot. So and they're self-insured in this case, but you know, regardless, it's a huge impact, right? Which should be a huge impact to their insurance premiums and how they would be viewed from the insurance world. So you know, you're preaching to the choir, as they say, right? Like, I love your idea and I love your thought, and I think more and more customers are going to start to realize that healthy, safe, productive buildings have a benefit in all these different areas. They're soft benefits, and I can't go to somebody and sell an engineer that's running a building on insurance reduction today. But at some point in time, you know, I think you're right. I just think people are going to realize that there's really good, healthy, productive buildings, safe buildings, and then there's bad buildings.
Llewelyn, another brilliant John Butler idea that's going to make somebody else a lot of money.
I would like to, poor John, you've got to forgive him. He pretends to be professor. but he's obsessed with money and acquiring a lot of it quickly.
Well, I'm an American.
He's an American professor.
I recognize that. You've got a bit of competition there. About 320 million people have much the same idea. Listen, dear boy, Dan, what about smart grids? Are any of your buildings incorporated into smart grids, and how does being in a smart grid affect the building?
Yeah, I mean, it's buildings being some of the buildings we work in and with are involved in a kind of a growing smart grid demand, and that's just really basically buildings being adaptive as they're attached to the grid, so they can draw energy, and in some cases they can give energy. There's actually net zero is this building's net zero building. It's not consuming any energy from the grid. Actually, in the future, there's a lot of times, actually in California today, there's a lot of times where buildings actually could contribute back to the grid to provide energy back to the grid, right? They kind of talk about that today with cars, right? So the built environment certainly is moving in that direction. It's got obviously battery storage systems and microgrids and all that kind of stuff. They're going to continue to expand over the coming years. So the smart grid is it's going to be along with the buildings, right? So you have your supply side and your demand side. Those two things are connected. So the smart grid is going to have to be adaptive to the building's demand and potential supply, and then they're going to get more intelligent and more adaptive, just like buildings are, over the next 2 decades. They have to, right? So it's interesting, and yeah, it's really, really big evolving opportunity in the future. And we again, I'll leave you with this though, is this efficiency first mindset. I just was speaking at CERAWeek down in Houston, 6,000 people present, talking about the future energy transition. And it universally is now understood. I mean, this efficiency first mindset is very important. Like, we have massive load reduction in the current operations of the world, that we can get 25, 28, 30% reduction of where we operate today by doing efficiency. That's going to make it a much easier problem to solve for smart grids, for clean energy supply, for hydrogen. You got to get the waste out of the system before you can solve these other problems. And even if you do solve these other problems, it's going to be much more economical, much lower spend to do it if you get all this waste out of the system. So I just want to stress the super importance of efficiency. This is the stuff we can do today. We know how to do it. We can implement it. It's good business for the people that are doing it. They save money directly in their pockets. Their operating costs drop. They provide better environments.
There's something that's almost anecdotal, that anybody who travels knows that outside of the US, but particularly in Europe, you're very aware of institutional efforts to save money. Your hotel, the lights go out when you take the key out of a little breaker on the door, which is rather useful because you can find the key, which is more than I can do most of the time. Then they have escalators that have a sensor and start operating when they're customers. They don't run when there's nobody around. And yet we seem to be very indifferent to those efficiencies in the US. When you start making a building more efficient, is that included in your purview?
Yeah, I mean, it's not in our Aircuity's purview, but I think it's definitely in the future of the built environment and future of more smart efficiency buildings.
More sensors turning things on and off when they're not in use or not needed.
And that's what we do for ventilation, right? So it's what I used to do in lighting back in the lighting days. It was basically providing dynamic control of lighting. So dimming when you need it. It's light, walk into a building, lights come on automatically. You don't have to think about it. There's a lot of technology out there that smart buildings can. They're proven, and it's all in an effort to get rid of the waste and to make them more effective at what they're really trying to do. And again, I would just stress the point of, like, specifically buildings, what we do. Well, at least commercial buildings and a lot of types of buildings are going to be more variable occupancy going forward. So they are going to have to be more adaptive. I think that's an important point to consider.
Yeah.
Thank you.
Let me couple of things that I need to do before we wrap up here. But if you haven't read my book, The Advanced Smart Grid, which came out first in 2011 and it got refreshed in the second edition in 2015, you all need to pick up chapter 7. Those of you who are listening and watching, we there coined a term called positive energy buildings. When in the future every building will become its own power plant, both commercial, industrial, and homes. And the grid and the production of the grid and management of the grid will incorporate this balance between prosumers and the utilities. And obviously everything that we're talking about is sort of walking into that. And then the other thing that I wanted to remind everybody real quick by sharing my screen is the notion that that we are excited about our event coming up. If I can show you my screen real quick and talk to you about the Digital 360 Summit coming up September 6th through the 6th through the 9th, I'm sorry, in South Austin. It's going to be fabulous. These are the companies that sponsor and spoke last year. And we want to remind everybody also about Texas State University, the CIEDAR Consortium, and the Smart Living Labs, and every building that we're creating on 700 acres, a million square feet of construction will be zero energy, zero water. And I want to thank Texas State for sponsoring the Digital Roundtable today. Dan, we're happy to have you. We would like to maintain a relationship with you and keep track of how you're doing. Any parting thoughts on your company and anything you want to let us know about what's coming up?
No, I want to say thank you for having me on, number one. Number two, I really enjoyed meeting you. I love the energy and the vibe of this conversation. You guys are all great. I am thinking that Villanova is going to win this weekend, so I got my fingers crossed on that.
Hey, all I can say is that it's really appropriate that the best four blue bloods showed up at the Final Four.
The Final Four, yeah.
Go Tigers! Go Tigers!
Yeah,
and hook 'em.
Yeah. And lastly, I just more than anything, not just Aircuity alone, I just very happy to be involved in this world and this environment of providing healthy, sustainable future for for the planet and for my families and my kids and all of our kids and the future. I mean, I'll tell you, leaving CERAWeek, I've never been more optimistic of seeing major corporations and all the big corporations and many from Texas that go to there, because this event was in Houston. Finally really nodding our heads all in sync with saying we are doing this energy transformation. This is real. This is going to be, well, I think they were reporting I can't remember, it's $50 or $500 trillion industry by 2050, and it has to happen in order to save the planet. So I'm very, and I used to be kind of saying like people just didn't realize about efficiency, or kind of they waved, that people are busy thinking about other things. And it just seems now that this is a very, very real commitment for the world. And I just want to do our part and hopefully continue to help our customers and continue to make real advances, I think, for in this space. That's what I hope happens.
Absolutely. Gentlemen, any final thoughts for Dan?
But Dan, I think that your next business model is what to do with all of that data. I think your business case, and if you look at smart cities and business cases, and how can you create business cases from all of the data that you will have about smart buildings as they interact with smart cities.
I'm so glad, Dan, that you're doing something about the terrible waste that goes on in buildings, waste of energy particularly. And I'm glad to see that there is a new discipline of work, and that you're also going after internal air quality, which I think has been overlooked always. My one thought is, how much ancient technology can you use in modern buildings? If you go to Qatar, for example, you'll see ancient buildings where they have a system of natural ventilation to try to keep, and they need it because it gets up to 145 degrees. Does some of that come into play when you're working with a building? How much of that traditional system is incorporated into modern systems?
Yeah. I walked the. I was just was in Scotland visiting my son who's studying over there, and then I think eons ago I walked the Alhambra in Spain where they had all those kind of natural cooling systems with running water through the building and everything. I remember that well. But we actually, what you're seeing in building designs, you are seeing more operable windows. You're seeing more natural ventilation buildings. We worked on a few of those, and so those older those older strategies are actually, you know, say in vogue, but they're actually kind of common, especially depending upon the environment you're in, like California or Australia, where they have good environments for large portions of time. So it's actually, with those, it's just as important to monitor indoor as outdoor air quality and to know when you can open those windows and when it's, what the air quality outside is and when it's safe to bring in that outside air and use that ventilation and not bring in a whole bunch of humid air that's going to put mold in the building, et cetera. So, you know, what we do and how we do it doesn't really change. But I think to answer your question, which is, I actually love, I've had an office since the pandemic kind of near my house. It's kind of a, you can see it's kind of a small office here that I've operated out of when we weren't allowed to travel. And but I love opening my windows when it's nice out. I'm the first one to do it. So I totally understand that. And in fact, we worked on Apple's World headquarters, and they have a naturally ventilated building. You know, it kind of brings in outside air and takes it through the roof, and that helps with ventilation, helps with productivity and wellness. So see a lot of that today, and you see a lot of buildings incorporating those strategies where they can, right? Because it's very, very important on, you know, it's a lot harder to do that in some really extreme environments, truth be told.
Thank you very much, and thank you for being with us today. It's very interesting.
Thank you, Dan. All the best.
All the best to all three of you.
Good luck. You're doing the Lord's work. Bye-bye.
Johnny, take us away.
There is a building in New Orleans they call the Rising Sun.
That's good.
It's been the ruin of many a poor boy. God, you know that I'm one.
Thank you, gentlemen. Thank you very much.